Thank you for staying for my talk. Well, I'm just going to be very, very real quick, just kind of maybe help you to make your work a little bit easier. But how are we going to make it easier? We're going to use revision control, which is something that I really like. So I'm going to teach you a little bit about or maybe just give you an inspiration of how it can be done. So yeah, these are just my contact details. If you want to, you can find me on Twitter. But anyway, let's move on. I just want to know a little bit about you all. So who handle data at work? Yeah, quite a few of us. So yeah, nowadays, no matter you're a data scientist or a machine learning researcher, we all handle data. But we know this before, right? We all have one struggle that I think I experience quite a lot. That Does this look familiar? Does it look like your folder somewhere, or maybe the emails that you send between your teams? There's so many different data that you probably maybe have cleaned up a little bit, or do some feature engineering and decided, oh, the string needs to be converted to numbers and numbers to string, whatever you're doing. And you train your model and you probably fine tune it a little bit, run the experiment again and train it again, and you have many models. So yeah, this is not very nice. so many things. And so why am I telling you this? Because, well, I am an data scientist. I'm now not a data scientist, but I'm someone who is advocating for ML ops. So that's why I'm telling you this. I love open source projects. So I'm quite lucky that right now I'm working for TerminusDB, which is an open source graph database, which you can do revision control. That's why I'm telling you about this. Also, I organize quite a few events. I know it's a little bit difficult to see, but I will tell you a little bit more about an event that's coming up next month. So also I stream a little bit during the pandemic because we all got bored and nothing to do. So we stay at home and do something crazy. Yeah, I do believe that we should make our life a little bit easier. It should not be having many stuff that you save around all your folder, it all tangle up, and then after a few months you don't know what they are. Are they a good model? What parameter you use for that model is just a little bit crazy. Many Jupyter notebooks, and then you don't know what they are, and stuff like that. It's oh. So let's figure this out, okay? So a lot of times, because I work. Like I said, I work in a lot of open source projects. So one thing that I noticed as a data scientist before, that engineers are very good at solving problems because that's what they trained to do, right? They see a problem in real life or in programming, then it's they solve the problem, they fix the bug, or they find a way to do it that is good. So let's see what they do with this kind of stuff, right? Have you heard about Git? Yeah, it's so silent, some nothing, yes. I'm glad that you have learned about Git or know about Git or maybe using it every day. So Git is quite good, but just to make sure that everybody's on the same page, Git is what we call revision control system. So what does that mean? Well, it means that, actually fun fact about Git, when it started, because people are working together, so they are sending code via emails and stuff, and then they don't like it. That's why they invented Git. So you basically just send all the changes, and also pull request is actually a message saying that, oh, I've made some changes, please merge it. So yeah, this is mainly what I would say that Git can do. Branches, you can the project that's going on, very nice, and then I want to do some experiment and change it a little bit, but I don't want to delete what I did, and then someone can work on it, and then at the end of the day I can either combine the work that I've done, which when we all like it, we can combine it, or if I'm just messing around, I can just delete the branch. So that's really good feature that you can work on your own version. Everybody can have their own version, and not contaminating the whole the root of it, which is the main or master if you're working on the old repo. So we all have this experience. If you, for example, have you ever opened a Google document and then you all edit the same document at the same time? It's a big mess, right? All the cursors are running around, and then you delete something, someone adds something, and it's oh my God, don't fight with me. So if you do branches, everybody work on your own version. You don't have this problem. Rollback as well. Rollback is because You know, we all love playing games. At least I love playing games. And when I was a kid, I played a lot of games. And then I am a safe, low, crazy person. I save a lot and low a lot because, for example, I made some bad moves or like I did something that is bad, then I can roll back. You know, I can load the save file. So, so basically, this is helping you, right? You can, if you don't like your work or mess up a little bit, you can always go back. Or made a mistake, don't worry, go back. It's fine. Also, we have Diff, which is when you have different branches, right? You and your colleague work on different stuff, do different experiments. It's quite cool. You want to see what's the difference, right? So, for example, you have a set of outputs that you maybe you want to compare them. Then you want to have a diff. And merge at the end of the day, you know, right? You compare the difference and then choose the best that you want or something. You can merge it back to the main one, the ground root of truth or something like that. You know, you can go back to the main thing. So yeah, we all need this. So that's what Git is doing. Yeah, we have this. Also, Git is really, I would say that very important for the open source movement because, you know, without that system of collaborating with people that you may not know very well, you know, because we can all work on the same thing, but we are not sitting together, or I don't even know you, that I'm not having a call with you or do some pair programming, but we can still work on the same thing and not tripping on each other's toe. And that's why with Git, we can actually do open source projects, because I don't necessarily need to know all this person who work on this repo, but you know, like I can, you know, contribute, and there will be someone who is like most knowledgeable one, who are the maintainers. They can decide whether this work, you know, your work is good, then merge it, or not, or maybe you have to fix it before you merge it. That's why it's like, you know, we all love Git, and that's why revision control is so important to develop softwares. But can we do that for data? Can we do that for database? Like, I mean, well, I'm not kind of technically a developer. I'm not an engineer, but I work with data. So can we do that with data set? But it's not ideal, because like I've tried that before. I have tried, for example, I have CSVs. They could be too big, and GitHub don't like it because it's too big. So I can't do it on GitHub. I can't share data on GitHub, even though they may be open data that I don't mind sharing. And also there's another problem, because like if you have CSV, right, and sometimes you make some changes to some column, maybe you delete something because they're not relevant anymore. When you do a diff, you see that it's crazy, because everything got changes, because Git is work on a kind of a text line-to-line basis to compare the changes. So it doesn't work very well with tables. If I make some changes to one column, Git would just think that you changed the whole file, because every line got some changes. But I'm only changing one column. I'm not changing everything. So it doesn't work very well. So maybe if we have a database that I can store the data, and it also have some Git-like feature that is like a revision control. So I think this is something that we all dream of. That's why there are actually multiple databases that can do that. I think you may have heard some of those, like DBC, maybe some of you have heard it. But today I'm going to mainly talk about TerminusDB, because that's what I'm familiar with. And so that's why I'm going to show you a little bit about how it works. So yeah, first of all, let's talk about branches. So a little bit fun fact about TerminusDB. So it's a graph database. So if you know how, if you've seen a Git tree, right? So all the diagram of like, all these commit in Git, like how they link up together, it looks like a graph. So naturally, you think if a database is, is built on graph, then you could do this kind of things, right? Or this Git thing. Branches is just a very natural thing that we can build in TerminusDB, so it's available. You can also create branches at any commit. So this is very similar to Git operations. Let me see if I can show you a little bit of that. So yeah, I got this is this is the terminal, but let me see if I can do a better job of. Sorry, I'm not very organized in this part. I'm not very well thought before, but typing with one hand is funny. Okay. Yeah, it's fine. So let me zoom in a little bit, even though this is it's not trying to show yet. So I want to, sign up, I want to sign in. Let me see. So yeah, wait, well, whoa, sorry. So let me get to the point that I want to show you. I'll show you. Can I sign in, please? Thank you. So I do have an account on Terminus. This is easy to show you. That's why I'm like trying to do this. I've already saved here. So yeah. Okay. So now I can zoom in and show you this stuff. Okay. Okay. So I have a few things that I've done before, right? Just like doing a lot of experiment and stuff. So this is just to show you what it actually is, because like with the command line interface, it's not difficult to visualize. Like it's quite difficult to visualize what it is. So I'm just doing this. But if you have a look, like what we can do is that everything is a graph. So we can have a schema. So like we have different objects, and that's how they relate to each other. So this one, I think is I think it's a phone book or something. Yeah, document. Yeah. So there are some employees, and then they have different addresses and things like that. And yeah, so this is all the employees and stuff. It's just a demo. But what I want to show you is that actually, if you look at here, that with all the activities. So let's see if I can. Yeah, so you can see there's actually 2 commit here. There isn't a lot in here. Maybe there's more on the other ones, but you can see that like there are different commits. So these are different times. Then you can see when I made these changes, and then like it's done by who. So I'm the admin of this profile, so it's admin. So like I have created schema, and I've added 4 employees. So this is what I've done. Is there anything that's more? So there's the same thing more or less. Oh, well actually yeah, like this is more operation. You can see more commit has been done. So other stuff as well. So there's more as well. So there will be. So here then. So what am I saying this? Because like with all these commit, you can actually also create a new branch. So here you can go to a new branch. Hello. Okay. Yeah. Sorry, I'm just randomly clicking things right now. Maybe I'll show you in. Oh, here branches. Yes. So currently you're in the main branch. You can switch to another branch. So you can add a new branch. So this is exactly what you do with Git. Yeah, it's very difficult to see because I've zoomed in too much. Sorry about that. So yeah, you can also create a new branch. Like you can name it something else. Try. Yes, why not? New branch. And I've created a new branch. So now I have 2 branches. You can see 2 branches. I know it's a little bit too small, but if it's big, the layout is gonna be strange. But yeah, you have 2 branches here. Right, so you can actually, now I'm on a try branch, I can try stuff, and if I don't like it, I can just delete it, right? So cool. And so this is branches. So let's go back here. Right, so let me do this magic here. Okay, so and rollback, like you see before, all the commits are there, so you can actually easily roll back to different commits. Like for example, can I mess with this? There's only 2 commits. Maybe I can mess with this one. Let's see. So if I click on it, you're coming. Yeah, you're in the main branches. So I can do the branches, and then I think I can roll back here, or I can use the command line interface to do that. So yeah, I'm not going to spend too much time here because I use the command line. That's why I'm not familiar with this. But you can do that with the command line interface. I hope that I can show you at the end. We'll see. We'll see. But let's go to the exciting bit, which is the diff. So diff and also patch is something quite new. That is now the dev team is very, they work very hard to make it happen. So why is this important? Because you can compare 2 objects. You can compare, so like I said, you don't want to compare things like Git because everything is a text-based. So it's not very nice when you, for example, we store things in JSON files. So actually all the graph here, you can actually see them in JSON. Let me see, for example, the schema, you can see that in JSON view, right? So it will be like a JSON like this. So if you compare JSON, what problem could you have with Git if you compare JSON? Can you think of why it doesn't work in Git?
I think it doesn't look into the actual content. It just look at the file and it says if the file has changed or not changed, but not the content inside the file.
Yes, exactly.
Any changes means that's a new file.
Yeah, exactly. So there could be 2 objects in this this thing, right? Then the order can change. You have 2 objects in it. So actually, you don't really care which object comes first. You can sort it so you have a coherent order, but it's not necessary all the time is the case. So yeah, the content is ignored, like you said. You just look at the text file. And then if the order changed, like actually content-wise, it doesn't change it, but then if you use Git, it will think that, oh, you changed everything. Again, like, I didn't change everything. Please don't blame me on that. So yeah, so that creates a problem. So yeah, so that's why we want to do this. We want to do a diff that actually can work with a JSON. So actually work on any JSON. So let me see if I can show you here quickly. Okay, so here we have an example here. Is it too small or too big? Because there isn't many of you here and the screen is very big. Okay, so actually this is a public API. You see there's a HTTPS here. This is a public API, so you don't have to sign up to use it. You just connect to it. If you want, you can take a picture of this. Or this is actually on our GitHub. So if you go to TerminusDB tutorials on GitHub, then you will find this. Yeah, you see that actually this is a public API, so you can just try it out yourself if you want to. So I'm using the Python client here, so that's why I can create some Python object, and then the Python client will translate it into the JSON for me. I just call it diff, and then it will just have the diff of these two things. So let me see if I can just print out this one first. Yeah, again, like it's very funny to have one-hand operation. 1 second. Oh. Okay, come on. Yep, okay. So now it's just running this bit. So let's see how it works. So let's do this. Python. So this is demo. Okay, yeah, cool. So okay, now you see that there's a lot of things. What's going on? Like like I said, the Python client will translate these two Python objects into JSON, and they will get compared. So what happened here is that, if I go back here, yeah. So you can see that, well, something has changed, right? I have changed the name, for example. Name I've changed from Jane to Janie. So you can see that the value has been swapped. So there's a before and after, so it has been swapped. So there are other things that's just describing like, oh, there are two objects there, so they have been different objects because, so there's some internal IDs that has been changed. So let's look at something that's more straightforward. So let me ignore this bit and do the other bits 1 second. Okay. Okay, so this bit, we are actually like, this is more spelled out. So oh, by the way, also you can patch it. So that result that I just printed out, you can actually give it back to the Jane object, and then afterward it will just go back to Janie. So it just means that it go both ways. You can, calculate the difference, and then you can, so the difference is now called patch, and then you can apply this patch back to the before object. You have an after object from it. So it's just kind of like, 1 plus 2 is 3, and then 3 minus 2 is 1, something like that. So this is more spelled out. You can see that, let me mute this as well. So yeah, you can see there's 2 JSON file here. So again, similar thing, instead of quite hidden as a Python object, it's just spelled out here. You can see that actually this is actually the diff that we have. So this one should be more clean than before. So let's see. Yeah, well, more or less the same. So yeah, again, like you have two things, and then like it just, so it was, I told you it's the same thing. So yeah, it's again, Jane become Janie. So this is the difference here. Yeah, so what's the other thing that I could show you? Yeah, you can play around with this. I think, yeah. So, this is the interesting bit. Okay, so let me unpause this as well. So now instead of printing it out, I apply the results back to Jane, and then this should give back Janie. So so you can see that after the patching, it should go back to Janie. So this one should give me true. So let's see if this is true. So it's difficult to see. Let me clear that. Sorry about that. Let's see, what's the thing? Oh, sorry, I haven't saved it, right? So sorry about that. Okay. Yeah, one-hand operation. Okay, so yeah, this time you can see that it's coming back as Janie. So the Jane, after the patch, it becomes Janie. So because this name is Janie, its name is not Jane anymore. And this doesn't give me an error or give me a false because they are equal, and assert is a pass because they are the same. So I think that's all of it. I want to keep this short because I think it's almost 8. Yeah. So yeah, I think that's that. Oh, before I let you go, I always forgot this. Is the most exciting thing at the end of the slide is that I will tell you about an event that's coming up next month. So let me see. Oh, merge. I already talked about that. So okay, you can try doing different like a Git-like operation with your data. I think it's really helpful. For example, the last thing I want to tell you is that for example, you can create, because the thing is that TerminusDB, you can put a binary string, a binary object, binary string. You can convert a binary into a string and then put it in the database. So if you train your model, it's a bunch of numbers, so you can convert into a string and you can stay. So you can do revision control with your model if you can make it into a binary. You can revision control your parameters. You can also have a schema, so you know what that parameter means. It's very powerful, but I think that the next step will be I'll build a demo especially for that use case, but it's not done yet, so I'm not showing you today. But anyway, so next month there will be PyData London, so it will be a 3 days conference, so tickets is available now. So if you want to, just go there and enjoy an in-person conference again. So it's just like not far, it's near Tower Bridge, I believe. So yeah, that's it.
So you support right now Node.js and Python. What plans do you have for the future?
Actually, the API is, you can use it directly, like the API you can use directly with curl. And we have always been asked that like, oh, what's the next client that you're building? The answer is like, we are open source. You're welcome to build your own client and contribute. We'll make you a hero on our Discord. So we'll love you if you do that. So yeah, up to you. Yes?
Yeah, if I understand correctly, the patch option appears to be very interesting. Can I assume, thank you. So can I assume that you can actually, let's say you have a production system, you can branch it, test it, and if the test works, then you can just extract a patch, which then you will apply to the production. So you're testing it safely. When all is good, then you just apply the patch and you don't need to manually update your production system. Am I right?
Yes, exactly. You get the idea. But what is even better is that because we are working on merge, so the patch, so it should be a single operation that you kind of, I want to merge this branch. So instead of you doing the diff and the patch yourself, it should be one single merge operation. So that would exactly work like what you mentioned. Yeah.
Interesting.
Yes. Joe is running.
Sorry for making you run. How big is the data consumption? Like if I have 3 different branches and in each of one there's only one column different, is really just this column saved or?
Yeah, so I didn't get a chance to show you the table diff. So we also have the table diff that so it's kind of like, it's very, very difficult, but like if you change just one column, that actually when you apply the patch, it will be more efficient than like if it's the text file. So yeah, like I think all the algorithm of the dip and stuff is, well, I'm not that smart. It's our engineering team, they are very smart and they figured out how to make it work very efficiently. That like, for example, you just make one change to a column. So instead of updating the whole file, it could be very big, right? It could be, CSV get big very quickly. They've got a lot of data. So you don't want to just update the whole file because that would be very costly. But if you can just, for example, if you make a lot of changes, but they are like, just one cell or column wise, then you could save the diff on top of each other. And then, so it will be more efficient than saving, this version A, and then make one change to one cell, version B, and then, you get, run out of storage very quickly. Yeah.
Yeah, it's more like a comment than a question. I work with virtual machines a lot.
Yes. You two should sit together.
In my workflow, I work with virtual machines quite a bit, and you want to do something on to update the OS, for example. So you take a snapshot, you might take another snapshot, and when you need to go back, so you can select which snapshot to go back to. And if you are all set, you can delete them all without actually affecting the virtual machine. And what you describe sounds somehow similar.
Yeah.
So when you snapshot a virtual machine, it's very quick because you just store the changes, not the whole virtual machine, which could be terabytes in size.
Yeah, so it's like exactly, so how virtual machine, like for example, Docker, how they work is like because they don't save different, images, they have, they save layer on top of each other. So it's kind of like revision control system is the same, like Git also, Git, I think I think people criticize me because I think I've looked it up before. Git actually does store the whole thing, but I think what we do is we are not like, it's a little bit different from Git, but we store the different layers of things. So so it's more efficient, first of all. If you have a lot of data, that's better this way. So Git is not for data, that's why Git do it differently. But we store the changes, so that's why you don't have to have copies of all the data all the time. So exactly like the virtual machine, because if each image is a separate machine, they will be big very quickly. So yeah, exactly.
Do you have a question? No, it's fine.
Yeah. Is that? Yeah.
Thank you.
Thank you so much. Thank you.